Hi, welcome to another episode of Science Made Simple. I'm Mr. Ryan and I'm a secondary science specialist here at the Pique Lab. In this video, I'll be analysing a past year exam question. I've also prepared this question for you to download for free by clicking a link in the description box below. So, let's get started. Let's take a look at this question together. In an experiment, a sample was vaporized, ionized, and passed through an electric field. When it says ionized, what can you think of immediately? Ions, right? Which are the two types of ions that you have learned about? The first type is the positively charged cations, and the second type is the negatively charged anions. As they pass through the electric field, they get deflected. Let us try to make some sense of the diagram below. Take a look at the two ions that are being labeled. There is Na plus as well as K plus. Can you tell me where they are flying towards? They are flying towards the negative plate. The reason is because unlike charges attract, so the positively charged cations are deflected towards the negative plate. So what is one factor that affects the deflection? One factor that affects the deflection is the charge. So positive will be deflected towards negative and negative will be deflected towards the positive. On the same line of thought, can we take a look at the unknown ion X over here? Where is it deflected towards? Is it the same plate as Na plus and K plus? No. X is being deflected towards the positive plate over here. So what does that tell us about the charge of the unknown ion X? Since it is attracted to the positive plate, this tells me that it is following this scenario over here. And that tells me that X must be negatively charged. If we take a look at the options, it becomes easy for us to immediately eliminate option 3 and option 4 because options 3 and 4 both show positively charged ions, whereas options 1 and 2 shows negatively charged anions. Now the question is, how do we select between options 1 and 2? Take another look at this question. Do you see any other clues? Do you see this bracket over here? If you don't know what this means, ask yourself, what does AR stand for? AR stands for the relative atomic mass. And the main thing that I want you to look out for here is the mass. How does the mass affect deflection? Let's try to make some sense using our two friends from the start, K plus and Na plus. Let us start by labeling their masses according to the bracket here. Sodium has a mass of 23 and potassium has a mass of 39. So which one is deflected more? Let us draw some arrows. Start by drawing from the center towards the K plus and draw another arrow from the same point towards Na plus. Which one has been deflected more? Can you see that Na plus is being deflected more? So what conclusion can we draw between the deflection as well as the mass? As the mass decreases, the deflection increases. Think about it this way. Is it easier or more difficult to push a lighter object? It is much easier to push a lighter object. Therefore, the lighter the particle, the greater the deflection. So keep that in mind. Now, can we take a look back at unknown ion X? Take a look at the deflection. Let me draw a line. What can you tell me about the extent of deflection? Is it deflected more or less? Notice that it is deflected even lesser than K. So what does that tell us about the mass of X? This tells us that X must be heavier than K, which means that the mass should be more than 39. Between Br and F, which one has a mass greater than 39? Take a look at the bracket again. Bromine is 80 and fluorine is 19. So which one is greater than 39? It is going to be bromine. So our answer is option number 1. Now that we have the answer, how do you think the other options will look like on this diagram? Let me draw F minus for you. Since F minus or fluoride ion is negatively charged and has a mass of 19, mass of fluorine is lesser than sodium. 19 is less than 23, which means that fluorine is going to be deflected even more than sodium. But Since it's negatively charged, it will be deflected towards the positive plate. So how I will draw this is like this. So that the deflection, as you can see, is even bigger than sodium. Now, pause this video here and try to draw for the options 3 and 4. In summary, from this question, we have concluded that the charge determines the direction it gets deflected. So positive ions go towards the negative end and negative ions go to the positive end. And the mass also affects the deflection. A lighter particle gets a greater deflection. Have you tried to draw it? So now I'm going to show you the answers. Hope you got them correct. If not, review this video again to make sure you understand the concept behind the deflection. Thank you for watching, and I hope you have enjoyed this video. Found this video useful? Give us a thumbs up and check out more by clicking the links over here. You can also subscribe to our channel for more interesting videos. Until next time, stay curious inside and limitless outside. Bye!